Now, so this is the fourth program which you are going to have. So in your fourth program which you are studying, so it is going to tell you that, so we have to write a program to add an array of 16-bit numbers. Okay, so you have to add the array of 16-bit numbers. So it is going to, we have to write a program to add an array of 16-bit numbers. Okay, 16-bit numbers, and store the result. So whatever the result you are going to get, that particular result, store the result in, and store the 32-bit result. Okay, so you have to get the 32-bit result in the internal RAM. So in the internal RAM is the title. Okay, so now how we are going to do that one? So as the program title tells, so all of you know already that how to add the numbers. So we are going to have the addition instruction. With the help of the addition instruction, you are going to add the contents of the two registers. So here you can see that they are specified the add an array of 16-bit numbers. Okay, so in the add an array of 16-bit numbers, so you are going to have the array of numbers, and then what are the array of numbers is going to have, that has to be added up. And because we are going to represent the numbers in your microcontroller in terms of byte, right? So because as I told you that, so your one memory location is going to store how many bytes of data? Can anyone tell? One memory can store how many bytes of data? 1 byte of data, right? So all of you remember that one, right? So you should know this one now. So now here what they are telling, how many bit of number you have to have? You should add an array of how many bit number? It is 16-bit number. So if you want to add an array of 16-bit number, so to store one 16-bit number, okay, to store one 16-bit number, so how many memory you require? How many memory you require to store one 16-bit number? How many memory you require to store 16-bit number? 16-bit is how many bytes?
2 bytes.
Okay, 16-bit is 2 byte. Okay, so now to store 2 byte of number, how many memory is required?
2.
Okay, okay, yeah. So number of memories required is 2 now. Now, for example, if I tell, so before that one, so since I have to have the array, this particular program can be written in two different ways. Okay, so one, directly I can initialize the array and I can store the number, or the number itself I am going to store it in some address. Okay, there are two ways you can write it. So that is left to you. Okay, how we are going to write that particular program. Different people is going to write when you go through the programs with your friends who are going to who are studying in your different college. So different college will form with us, go with a different flow of program. Okay, so now here, so here what will happen? So for example, so I'm going to store 0x. This may be the address from where you are going to store the data. Okay, 0x 4000. Okay, so now for example, I want to store 0x1122 is one number. Okay, and then second number I have to add is 0x3344 is another number. So the third number which I need to add is 0x4566 is another number. Next, the fourth number which you have to add is 1223. So these are the four numbers I need to add. So after adding, what is the result you are going to get if you add all these four numbers? Can anyone tell? So this is your first number, that is 1122. Okay, that is hexadecimal value. So this will be second number, this will be third number, and this will be fourth number. Okay, so now can you tell what is the answer you are going to get after adding all those four numbers? Can anyone tell by adding? Can anyone tell what is the answer you are going to get when you are adding 1122, 3344, 4566, 1223? What's the answer you are going to get? Can anyone tell? You solve it. So if you take 2 plus 4, how much is 2 plus 4? If you take 2 plus 4, 2 plus 4 is? Can anyone solve and tell? I will give 2 minutes of time for you people. You solve and give the answer. How much is the result you are going to get for this one?
10255.
So this is hexadecimal addition you have to do. You be careful with this one. Because I am specifying 0x, right? I am specifying 0x. So if 0x means what? It is hexadecimal number. So be careful when the number is represented. So if 0x is not there, then it is by directly decimal number. So if it is 0x, how we have to add? 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 3 is 15. Now in hexadecimal value, what is the value of 15?
F.
Yeah. So in hexadecimal, the value which you are going to get is F. So in the second number, what you are going to get? Any doubt?
No.
Anybody having any doubt?
Whole answer, sir. 9BEF.
Yeah. So the whole answer will be 9BEF. So how many of you are having still doubt? If you have any doubt, the one answer what you are going to get is be all 9BBF. So if you have a doubt, what you do is to have a clear understanding 0011 0001 0010 0010. That is nothing but 1122. So like similarly it is 0011 0011 0100 0100. So next it will be 0100 0101. So 0110 0110. So next it will be 0001 0010 0010 0011. Okay. So it is a bitwise addition what it is going to do. So here you can see it is 1. What you are going to get. So if you take this one is, it's going to have 1 and 1 carry you are going to get. So again 1 you are going to get, is 1 carry you are going to get. So all of you are following here. Is if anybody having any doubt in your binary addition? Anybody having any doubt? So if you're getting confused, whatever the binary hexadecimal value is there, you convert them to bits and you add it. So you'll get an answer. Okay. So here also the same 0. It is 1 plus 1 is 2. 2 is equal to 10. 10 plus 1 11. So here going to have 1 carry. That is binary addition. So again it is 1. 1 is going to be here. You're going to here. So 1 plus 1 plus 1 here. 1 you're going to have 1. You're going to get it. So again 1 1 1. Going to have 1 1. 1 plus 1 is 0. You're going to have 1 carry. So it is 1. So similarly it is here it is 0. 1 you are going to get. 1 plus 1 again it is 0. 1 you are going to get. Again it is 0. It is 1. So it is 1, right? Okay. So if you again bifurcate it, so this will be what? The first bit what you are going to have is 9. Okay, this will be your 9. So this will be B. Okay, this will be B. So this will be E and this will be F. Okay, 1110 is represented as E. All 4 ones is represented as F. 1011 is represented as B in hexadecimal, right? So now once you have that one, so all these values are now all these first number, second number, I have to store it in memory starting from 0x 4 followed by 7 zeros. So now can you tell what will be stored first in 400 if I am storing this particular numbers in the memory cell? What value will be stored? So if it is a whatever the microcontroller we are using, microcontroller, so it's a little endian. So if it is a little endian, how the data will be stored? If it is little endian, how the data will be stored? Can anyone tell?
Lower to higher.
Yeah.
Lower.
Lower byte, lower address. So now here in the first number, which is the lower byte? in 1122, which is the lower byte. Lower byte, lower address. The lower byte is 22. So the lower address is this one. 22 it will be storing here. Okay. So next it is 0x40000001. It is higher byte here. 1. Any doubt? Anybody having any doubt? Anybody having any doubt? Anybody having any doubt?
No, sir.
Okay. So the next memory is 4 followed by 2, 3, 4, 5, 6, 7. So now, if this is a second number, so if your 3, 3, 4, 4 is second number, what will be stored in this particular memory? That is 2. In memory 4 followed by 2. So what memory will be stored here? What is the data which will be stored here? Can anyone tell?
4.
Yeah, 4, 4. Next, in 3, what
3,
it will be
3.
stored? Yeah.
3.
In next 4, what data I
6,
can?
6, 6.
Yeah, 6, 6. Next in 5, it will be
4,
4,
4,
5.
5.
So next in 6, it is
2, 3. 2, 3.
2, 3 in
1,
1, 2. So
1,
now
2.
you have to store this particular 16-bit number in this fashion. Okay. Any doubt in this one now? You have to store the memory. You have to store the numbers into that particular memory in this particular fashion. So if you want to represent the number which is given. Anybody having any doubt? Anybody having any doubt?
No, sir.
Okay. So now this is the preliminary what you require for that one. Now I have to access the data from this particular memory when I'm writing the code. So where the data is stored? The data is stored from the memory 4 followed by 7 zeros to 4 followed by 607, right? So for your understanding, so it is a 32-bit address. Whatever the address it is going to generate is a 32-bit address. So that's why it with the size of the address will be 32-bit. Okay, so if you're calling with that one, it is a 4 crore. So 4 crore 1, 4 crore 2, 4 crore 3, 4 crore 4, 4 crore 5, 4 crore 6, 4 crore 7 is the address. Okay, so the corresponding elements will be stored in this particular fashion. So till here, anybody having any doubt? Anybody having any doubt? Because we have to start writing the problem. All of you have taken this one now? If you have taken, just tell me. So at least the right part, you take it in your book. The right part, which is the address which have been specified and the data which how it has been stored. So at least that particular part you take it in a book so that you will get understand when I'm writing the program. So anybody having any doubt? Once you have copied that one, you just tell. Once you have copied, whether you people have copied that one, I will give 2 minutes of time. You just copy it and inform me. Okay. Or it's over. So if you have completed, just inform me. So we'll proceed further.
Yes, sir.
Okay. So all of you have completed. So if you are sitting in front of the desktop, you just take a snapshot, a print screen of that one. That's it, and you can copy it later. Okay, so that you can do it. So make a habit of writing it instead of that one. Okay. So till now, anybody is having any doubt? No doubts, right? So now the next, I'm going to start writing the program now. So now, as I told you that, so you're going to have the data is stored in this particular address. That is 4 crore 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the corresponding element which will be stored here is your 22114433. So 66452312. Now I have to store write the program. So when you're writing the program, I have to add all these 4 16-bit number, and I have to store that particular number in one memory location. So now it is a memory related operations what I need to perform. So now when you are starting a program, what is the first part of the program which you are going to write in your key software? So that means I have to define the code memory. To define the code memory, I am going to make use of area. So all of you keep in your mind that from here, whichever the program requires memory operations, that is your load and store. Whichever the program is having the load and store instructions, so you are not able to make use of your browser based compiler. Okay, so that what you have done for the first 3 programs, right? It will not be supported. So when you are going to make use of the load and store operations, that is, it is not going to access the memory. So only thing is you have to make use of the key software only. So that is the only options what is left out. So that you install it when the college any non-teaching stuff are there. If you are free, you can go and get it installed. Okay. So now next is area sum. You are going to have the area. So next I'm going to add it, right? So I'm going to add it. So that is the name of the program what I'm giving. So the part of the code is code, and whenever you are going to define the code memory, that will be read only. Okay, that will be read only. So this is the first part which you are going to have. So then next, when you are going to have, so next is the entry point. Okay, next is the entry point which you are going to have. So when you are making the entry point, so first you are initiating the start program. So now first I need to get the memory location. So what is the value of that memory? I'm going to initialize it later. That is, I'm going to declare that particular memory at the end. So for that one, you have to make use of array. Okay, so you at the last you make you I have to define it. So because variables inside your kill software will be defined at the end, that you keep in mind. So with the variables will be defined at the end. So now for that one, at the last I'm going to define the variable. So you make a note here that always the variable defined in at the end. So now here what I am going to do is I'm going to load the starting address to the array, because the array is starting from the address 4000, right? So it will be starting from whichever the address you require. So that particular address has to be stored in the beginning of the array. Okay, so the array always will be having starting address, right? So that particular starting address I have to initialize to the array. So then I have to store the result according to the program statement. Okay, according to the program statement, how much data you have to store in the result. So it is 32-bit. Whatever the result you are going to get, that result what you are going to get, that will be stored in 32-bit. So now for that one, what you are going to have 32-bit to store result. If you want to store, okay, 32-bit result has to be stored. How many memory locations you require to store the 32-bit result?
2, 4.
4.
No, 4.
Yeah, because 32-bit is how much? 4 bytes. So if it is 4 byte, how many memory is required? 4 memory is required.
4.
Okay. So this is very important when you are executing the program. This particular thing, if you understand, so next all remaining 5 programs you are going to understand easily. That's it. The first thing is you should understand this particular part, how the data is stored in the memory, how to access the data from the memory, and how to store the data again into the memory, and the usage of your load and store instruction. How to use your load and store instruction efficiently, that you should know. Okay, so once it is start, next by using what instructions you are going to load the address? By using the LDR.
LDR.
Okay, so
LDR.
LDR is a, yeah. So from here I'm going to define the memory address. Okay, so array address I'm going to define later. So that particular array address, the starting address of the array, I am going to load to the R0, the starting address. I'm going to define the array at the end because the variables will be defined at the end in your assembly code. Okay, for that particular reason, I'm going to define at the end. So now, how many values I have taken here? I require one counter. So how many values I have taken here? For my reference, how many values I have taken? We have taken 4, right? So here, this particular part, it is going to give you loading. What it is doing, it is loading the starting address of the array. This particular statement is going to load the starting address of array. Okay, so this is going to load the starting address of the array, the first statement. Okay, so next I need to have the size of my array. So what is the size of the array? How many elements I have been storing?
2 by 2.
No, here how many elements we have taken as a reference? You
4,
added how many numbers? 4 numbers, right?
4.
You added 4 numbers. So that means the array size is 4. Because it is 2 byte. 2 byte of how much data you are going to take? This is 1. This is 2. That is 1, 1, 2, 2 is one data. 3, 3, 4, 4 is another data. 4, 5, 6 is another data. 1, 2, 2, 3 is another data. So that means 4 data you are taking. That is the array size is 4 now. The array size is 4. So that I am going to move it to one register. So move, because I have to keep track of the counter to add the numbers. I am going to load it to one register, that is R1. So this particular part is going to tell that load array size. It will load the array size. Okay. So next, I have to get the data from the number. So that is, I have to get the address. Where the address is stored now? Where the address is stored? Which register? Address is stored in R0. Basically,
R0.
R0. So now from that particular address, I have to retrieve the data. To retrieve the data from that particular memory location, what is the instruction I have to use again? Memory to the register. Again, what
Load.
instruction? Load. So how much data I have to retrieve? What's the size of the data I have to retrieve? There is a
4.
1 byte or 2 byte or 3 byte or 4 byte. How many bytes of data I have to retrieve? According to the question, how many bits? How many byte? According to the question. How many bits of, 2 bytes I have to retrieve. So to retrieve 2 bytes, what is the instruction? I have to use LDRH. That is load data register with off word. That is, I am going to load the contents of the memory location. How many contents of the memory location? 2 contents of the memory location. That is R specifies. If it is only one memory location, it is LDRB. Okay. So if it is a 4 bytes, it is LDR. If it is 2 bytes, LDRH. That you have to keep in your mind when you are going with the LDR. Okay. So LDRH R2, R0. Okay. So that means what? Whatever the value is there in R0 now. So R0 is pointing to 4 crore here. So this particular data it is going to take. That is 1122 it is going to take. And it is going to load 1122 into register R2. So your R2 now holds 1122 value. Your R2 holds 1122 value. So this particular instruction, what it is going to do? It is going to load 16-bit number. It is going to load 16-bit number from specified address. So that particular address is stored in register R0. So it is going to load 16-bit number from specified address, and the address is stored in the register R0. The address is stored in the register R0. So next, once I have taken the first data, I have to decrement the counter. So what I need to decrement? If I want to decrement the counter is the size of the array, or the counter is maintained by R1. So I have to subtract the contents of the R1. So subtract the contents of R1, R1 by 1. Because I have to add the next number. I have to retrieve the next number and I have to add the next number. Now, what instruction I have to use? Next, presently what the R0 is holding? Presently, what R0 is holding? Presently, what R0 is holding? Can anyone tell?
16.
Address. What address is holding? It is holding 4 crore. Your R0 is holding this address, right? That is the starting address of the memory location. Okay. So now, from where it has now retrieved the data, first 2 bytes I have retrieved now. Now, next, which data I have to retrieve? From which location I have to retrieve now? Next data?
R1.
No. Which memory location? First data is there in starting with the location 4 lakh. So next location, it is going to be in which location? Next 16-bit data, if I want to retrieve
2 lakh 1.
2. That is, it is 2 byte of data, right?
Yes.
Your memory is going to store, it is a 16-bit data. That means it is going to consume 2 memory location. Any doubt?
No, sir.
Anybody having any doubt? Any doubt? Anybody having any doubt?
No, sir.
Okay. So now what I need to add, presently my R0 value is 4 crore. But I have to retrieve the next data from which memory location? 4 lakh, 4 crore 2. So what I need to increment now? I need to increment the memory location, which is holded by R0. The memory location address is holded by R0 now. Presently it is pointing to 4 crore. Thus I need to increment to point to the next location of the number from where I have to retrieve the data. So that means I have to add 2 to the memory location. So for that one, I need the instruction what? Add R0, comma, R0, comma 2. Anybody having any doubt? Anybody having any doubt? Anybody having any doubt? Add 2.
No, sir.
Okay. Add 2. The next, from it now it will be pointing to after this one. So it will be pointing to where? So it will be pointing to. So it will be pointing to. It will be pointing to second address. Okay, pointing the second number address. Second number address here now initially. Okay, so now from that particular memory location, I have to retrieve the data. To retrieve the data from that particular memory location, what is the instruction I have to use again? To retrieve the
R4.
data from LD RH, to retrieve the data from the memory location to the register. Because already I have one number in R2, that is first number. So second number I am retrieving, that will be stored in R3. So the second number, I am going to load it into R3. So the load second 16-bit number. Load second 16-bit number into R3. Any doubt? Anybody having any doubt? Anybody having any doubt?
No, sir.
So now, where the first number, in which register the first number is? Which register the first number is?
R2.
R2. Where is the second number is now?
R4.
The second
R3.
R3. Still I have not used the R4. Okay. So in R3 your what is there? Your 3344 is there. Any doubt? Now what I need to do? Now I have to add these two numbers first. I have to add the contents of R2 and R3, and whatever the result I am going to store, that I will be storing in one register. So here I am going to take the references R2 only to calculate the total. Okay. So the next instruction will be what? Add. Add what and what I need to add? What and
R2
what?
and R3.
Yeah. R2 and R3. And the result has to be stored in which register?
R2.
R2. Okay. I will take my total to be represented by R2. Okay. R2 is holding the total value. So I am making my present total value as R2 only. Okay. Total to be calculated by R2 itself. So now I'm going to store the result of this one in R2. So next, what is the next operation I have to do? What's the next operation?
Retrieving again.
Retrieve again. Before retrieving, what I need to do? I have to decrement the counter because I have already retrieved two numbers. I have decremented the counter already here. One more decrement I have to do. So I have to do sub S because I have to keep track that how much time I have to retrieve the data, right? How much time I have to retrieve the data. It will be taken care by R1. So subtract R1 comma R1 comma #1. So it is going to subtract. Now, if it is not equal to 0, so if R1 not equal to 0, again I have to retrieve the data. Okay, again I have to retrieve the data. So branch not equal. So where I need to then to retrieve the data, where I should go? Again I have to add the address, right? Again I have to add the 2 to the present memory location, right? So where it is doing here. It is add R0 comma R0 comma #2. All of you can see here, right? This particular part add. So the location where it has to be shifted is this particular part. Branch are not equal to up. So the up will be here. The up will be here. So anybody having any doubt? Now you can ask if you have any doubt. If you have any doubt, you can ask. If you have not followed, where you have not followed, you just tell me. I will explain there.
It's the last step you repeat.
Branch are not equal, right?
Yes.
So now branch are not equal. Not equal, how it will work? Not equal when that particular condition will be checked. When your zero flag is 0, right? Equal will come equal when you are going to have the branch with respect to the equal conditional flag. Okay, so you are going to have the flag that is zero flag. Zero flag will be tested with respect to the equal and not equal. So now if the previous instruction has resulted in 0, then the zero flag will be set. Okay, if your previous instruction has resulted in 0, then your zero flag will be set. If the previous instruction has not resulted in 0, then your zero flag will not be set. So, any doubt in this one now? Any doubt in this particular statement?
No, sir.
Okay, so now what I am checking now here, I'm checking the counter for how many times I have to add it up. So previously I have already decremented the counter of R1 by 1. So now presently what is the R1? R1 is 3 here. So now here R1 will become what here? Here it will be 2 in this particular iteration. So when it becomes 2, whether it is 0, whether the content of previous value is 0? No. If it is not 0, that means it is not equal. Not equal means what? It is not 0. The previous operation is not equaling to 0. If it is not 0, where I have to go? The flow again has to go back to the up and it has to retrieve the next data from the next memory location and I have to add it. Right? Any doubt? Anybody having any doubt?
No.
Any doubt? Anybody having any doubt? Okay. So now once this particular loop is continued, next it what it will become? Next it will become 1. Next it will retrieve next location data it is going to retrieve. Next what the R0 will be pointing to, R0 will be incremented by 2. So now your R0 will be pointing to 4,04,000. Okay. So it will retrieve the data from the memory location 4,04,000. Okay. Then again it is going to add the contents with R2 and R3. So now after this particular result, your R3 will be holding the third value. Again R2 and R3 get added up. The final result what you are going to get, it will be stored in R2 again. So again I am going to decrement the counter by 1. So if it is not 0, it is not 0. Again it will go and access it last data which is stored in 4006. Okay. So now once it retrieves the data from the next location, you are subtract when you are doing the add that particular fourth element also here. So it will add the fourth data also. Again it will add with the fourth location. So next your R1 becomes 0 at that time. So your R1 becomes 0. So this particular branch not equal to up will fail. Your branch not equal to equals fail because now it is equal. It is not equal. Okay. So now when the R1 becomes 0, your carry flag, your 0 flag will be set. If your 0 flag is set, then it is equal, branch equal, condition satisfies. So now your branch not equal condition fails. Your branch not equal condition fails. So when it fails, it will come out of the loop. When it fails, it will come out of the loop. Okay. So anybody having any doubt now? Anybody having any doubt? Anybody having any doubt?
No, sir.
Okay, now next is I will get the result, and the result is stored in R2. The final result will be stored in R2. Okay, the final result will be stored in R2. So this particular R2, I have to load it to some memory address. So as per the statement of the program, what it is telling, as per the statement of the program, it is telling that we have to add the 16-bit numbers of array, and I have to store the result in 32-bit internal RAM. So that particular 32-bit internal RAM is nothing but you have to store the result in some address. You have to store the result in some address. Now I have to store that particular result in some place, right? So I have to store that particular result in some place. So what I will do, the final result is stored in R2 now. The final result is stored in R2. So again, I have to make use of the LDR instruction. Okay. So up to here, anybody having any doubt? Anybody having any doubt up to here? Anybody having any doubt?
No, sir.
Okay. So whether you people will write up to here or shall I complete, and I don't have the space, I will go down. Okay, no problem with that one. Okay, 1 minute. Okay. So now, next. So in the next stage, what will happen here is, so now I am going to load another variable, LDR R not comma result, where I should store this particular value. So the result is a variable. So this is a variable which I am going to declare later. So this particular variable will be having some value. So that value will be moved to the R naught. Okay. So next, once it is moved to R naught, what data have to move to the R naught? This particular address. The result. Result is stored in which register? R2. The result
R2.
is stored in R2. So now what I need to do? I need to use the instruction str. So from where to where I have to move the data? I have to move the data from R2,
Memo.
from the
R2 to
register R2 to the result memory to the memory. Memory is stored in which register now? Or not? Any doubt? Anybody having any doubt? Anybody having any doubt here? Anybody having any doubt? Anybody having any doubt?
No,
Yes
sir.
or no? That's it. Okay. So
No,
now,
sir.
once it is done, I am going to have the infinite loop which will halt the program. Halt unconditional branch, unconditional branch, it is going to halt. So that is nothing but it is an infinite loop. It will be looping on here itself. Okay. This particular branch is a unconditional branch B. So to stop the execution. So next I have to define the array. So array, I'm going to define it. So array is of type DCD. I'm going to store the address where the data are located, which is 4000. And I'm going to have one more variable, which is result. Result is also define constant double word, which is of 32-bit. The result I'm going to store in the address 4001, 4 crore 1000. Okay. So, and then end. So anybody having any doubt here, you can ask now. This completes the program. So if you have any doubt, you can ask. Can you people write it down once? Students? So just copy it down. You can understand, right? Students? Hello.
Yes, sir.
Can you write it by like this way, or I have to write it again? Neatly.
Sir, just scroll down, sir.
Okay, 1 minute. Okay. So if you have any doubt, you just ask once. So if you are comfortable with C program, shall I explain in that particular fashion? Over. All of you taken this one? Anybody having any doubt? Over? Once you completed, you just inform me. So completed. Okay, all of you
Sir,
done?
this won't work.
What?
This won't work in online browser, sir.
Yeah, online browser it won't work because it will not. It is not accepting the memory related operations. Okay, so if you are free, so you can go to the college. Any non-teaching staffs are there in the college. So you can get it installed in your laptop, Kill software, and you can work it out. Okay, so and anyhow, the Kill software is there online only. You can download it in the link I have shared. I think for you, right? For your class, I have shared the link. Anybody has seen that one? Yes or no? That's it. Nothing else. If you have not seen, have you seen or not? Yes or no?
Sir.
Huh?
Yes, sir.
You download from the drive. Okay, in the drive it's there. The software, whatever the link I have shared for you people, in that particular drive, I have stored the Kill software. You download the Kill software, so you can install that particular Kill software in your system, and you can run the program. Okay, so that is around 200 or 250 MB is there that you can download it. So that in the beginning only I have stored it. And even if you don't have the link, you contact your CR Kushi. Kushi is there in the class. So I shared that particular link to her. So if you want that particular link, you get it from her. Okay. So anybody having any doubt here in this particular program? Once I will execute and I will show it to you. Okay. All of you taken it? Lekana, over.
Yes, sir.
Yeah. Kirtana?
Yes, sir.
Yeah, okay. Okay. So we'll just execute this particular program. So clean macrovision. So all of you can see that particular screen, right?
Yes, sir.
Okay. So all of you forgot or remember the steps to open the project. I have already once again I explained this already. So all of you remembering or already forgotten? Yes or no? That's it. Simply don't waste the time. If yes, I will go from the where it is required. If not, I have to start from the beginning. That's it.
Yes, sir.
This part, up to this part, you know, right? Building the creating the project, you people know, right?
Yes, sir.
Okay. So now after creating the project, you have to add the source file. Okay. So after creating the project, so now when you are creating the source file, okay. So first you add new item because I am creating a new file. Okay, add new item to the group. So when you add new item to the group, you can see it here. So it will provide you the new option. So the options you are going to get. So the options which you are going to get, it will be have C file, whether you have to create a C file or C++ file or ASM file or header file. So now what we are creating is a ASM file. So what your people are creating is a ASM file. Select ASM. Select ASM file and then give the name of that particular ASM file. Okay, so here I am going to have the array as array addition. So just I am going to give add array. Okay, I am going to give the file. Say, so that particular file has been created and it is added under that particular this one project. Okay, so next start typing the program. So always in the beginning, if you are going to have, so give some space, area you define, area code type of the area is code, size, name of the name of the program is you give, that is array addition. I am giving some name, that is left to you. What's the name you are going to give? Array addition I am going to give. So next, this part of the memory is code memory. So that is code, you specify code. Okay, so after code, that particular part of the code is only read only. So you're going to have only the read only memory. So after typing this one, okay, so next is your entry point. Okay, so you are going to have the entry here, entry. So next, the code will start. Okay, so that is for your reference. Okay, you are going to provide you the start. The start has to be begin from the first row only. You should not have the tab space. Okay, the start has to be start from the beginning only. You should not have the tab space. That you have to keep in your mind. So the first instruction what you are going to have is LDR. So LDR or not comma array. I'm going to have this one. Okay, or not comma array is the address. This one. First instruction which I'm going to have. So next, it is going to load the starting address of the array into the R0. So next, I need to have counter. So this particular, you make a type documentation in the such a way that, so it will be helpful for your understanding. So that is what you are in your software engineering. So have you heard the term self documentation in your software engineering? Have you heard the self documentation? Heard or not? Not starting. So this is what the self documentation refers to. So it will load the starting address of array. Okay, load starting address of the array. So next, counter you should have, that is the array size you should have. What is the size of the array? So here I'm going to take the size of the array as 4. I'm going to load the size of the array into the size of the array. I'm going to load it into register R1. Okay, so that will be the size of the array. Okay, so next, once you have this one, I need to load the data from that particular memory location. That is the first element I'm going to load. So first element I'm going to load. To load the first element, LDR H. To load the first element, LDR H. So I'm going to use it in R2. LDR H R2 comma from R0. From R0. LDRH R2 comma contents of R0. So what it is doing, it is going to load first 16-bit number. Okay, it is going to load first 16-bit number into R2. Okay, so next, once it is loaded, I have to decrement the counter. So it is nothing but size of the array, which in turn it is keeping track of the count. Okay, it is going to be counter. So that is how many times you have to repeat and how many times you have to add it. Okay, so that is going to keep track of that one. So I have to decrement the size of the array now to point to the next location. So subtract the contents of R1 by 1. Subtract the contents of R1 by 1. So decrement counter, this one. So the definition for this one will be decrement the counter. Decrement counter you are going to have. So next, once this is done, I have to point to the next location. Okay, so the point to the next element of the array. So to point to the next element of the array, so it will be address from which I'm going to load the data. So the address is stored in R0. So since it is a byte, 2 bytes, a 16-bit information which I have to retrieve, so I have to add the contents of R0 with 2. Okay, so I have to add the contents of R0 with 2, comma hash 2. You are going to have. So this will be pointing to address. It will be pointing to the second element. Okay, or next element. So next data of the array. Next data of the array. So it will be pointing to the next data of the array. Once it you are retrieving, pointing to the next location, I have to retrieve the data from that particular location. To retrieve the data, again LDRH. Okay, so to retrieve the data, again use LDRH. So LDRH. So I'm going to store that particular data in R3. So initially I have stored that one in R2. So now I'm going to store in R3. So from where I'm going to fetch the data? From R0. The address is stored in the register R0. So it is going to load the second data. So here going to load the next 16-bit number into register R3. Okay, into register R3. So once it is done, so I have to add the contents of R2 and R3. Add R2, comma R3, comma R2. So what it will do, it will add the contents of R3 and R2. The result which it is going to get, so that will be stored to R2. Okay. So next I need to decrement the counter. So that is subtract S, the contents of R1 by 1. So why I am using the sub S1? What is the significance of using the sub S? Why we have to use the sub S? Can anyone tell? Why not sub? Why we have to use the sub S?
For two memory locations.
Huh?
Subtract two memory.
Yes, yes suffix tells what? When you are going to make use of the S? Can anyone tell correct answer? Is that all of you have forgotten already second module? Sub S is used when you want to do the operation and simultaneously you have to update the flags. Can you remember that one now? Can you remember sub S? It's going to, after performing the operation, it is going to update the flag. Okay, after that one, branch not equal to. Where I need to do? I need to again press the next element and I have to retrieve it. So branch are not equal to up. So the up will be coming here. Okay. So you are going to have the up here. Okay, so you can have this up here. So once it is done, branch are not equal to up. So once the loop is completed, you are going to add the numbers. So once it is added the number, I have to store the result. So that is to store the result, RDR R0, comma result. Okay, so that we are going to declare at the end. So then I have to store the result which is there in R2. To where? To R0. To R0. So my sincere request is go through the instructions regularly. At least when before the class your lab starts. So or if not, so I have given you the PPT one right. So of the instructions, you keep that particular instructions PPT along with you. So then it will be helpful for us also to go fast. So next here it is going to store the result here. So it is going to store the result in the address specified by R0. So next I am going to define the halt. So here unconditional branch I'm going to do. So halt branch halt. So this is a infinite loop. It will be keep on running. So it is an unconditional branch. So unconditional branch which you are going to have. Once it is done, I have to define the variables now. So what are the variables I should have? One is array. Array is one variable of type double word. So that means this particular array contains the 32-bit data. So what 32-bit data it is going to have? It is going to have the starting address of the memory location where the data is stored. That is 4 4. Okay, 4 followed by 7 zeros. So that you have to keep in your mind. So this is nothing but what? The starting address of the array. So starting address of an array. So next I have to define the result. I'm going to have the result DCD. So I'm going to define it and I'm going to store that particular result in 4100. Okay, 4 crore 100. So here, so the address to store the result. Okay, this is the address to store the result. Okay, so this is what it is going to have. So once it is done, end. So here you are going to end it. So once it is end, so you compile the program. Okay, so once it is done, compile the program. So to compile it, first you go under adder build target. So first you save it, save the file which you have been created. After saving it, you go to this location, build it. So if any error is there, it will show whatever the error is there. So now there is no error, it will show there is no error. So now once it is done, I have to run the program now. To run the program, go to debug, start our debug session. So it will display you that running with code size limit 32K. That means since it's a trial version evaluation mode, so the only code which you can write can accommodate only up to 32 kilobytes of size of the code. Okay, that is the thing what it is going to do. So press OK. So once it is OK, your program starts running. So now once the program starts running, so you define your values. From where I have to store the value now? I have to store the value from 4 followed by 5 zeros. Okay. So I'm going to have this particular value 4 followed by 7 zeros. Now what is the value I have to store in this first location? What value I have to store? At the bottom you can see it here. All of you can see the bottom memory location. Can you see the bottom location where I have pressed 4 crore? Can you see?
Yes, sir.
Yes, sir.
Okay. So now in the 4
Yes, sir.
crore location, what is the value I have to put? Manually I have to place the values now here. So what value I have to put now? First, lower byte I have to put. That is 22 first.
2,
Next, it will be 11.
1,
Next,
4, 4,
okay. Next,
3, 3,
okay. Next,
6, 6,
next,
4, 5,
okay. Next,
2, 3,
okay. Next,
1, 2.
1, 2. Okay. So now I have stored the data in the corresponding memory locations. That is 1122, 3344, 4566, 1223. Now with this particular data, the program has to run. Correspondingly, the values of the register will get changed. So I will start programming. So once the program starts, the instruction is pointing from where this particular execution is going to start here. You can see it here, right? So now it is now this particular starting point of the execution is pointing to LDR, R0, comma array. So it is going to load the array into array is the variable. Variable is nothing but what? Named memory location. So giving the memory location, for that particular memory location, some name is given. What value I have stored in the array? I have stored the value 4 crore. This is nothing but the address. So from that particular address, it is going to load the beginning address of the array. Okay. So when I press next, so your R0 will be having what? You can see it here. In your registers window, your R0 will be having, all of you can see, R0 is having 4 crore. Anybody, all of you seeing this particular part? Anybody having any doubt? Anybody having any doubt? Anybody having any doubt? Can you see this particular window? Registers window by the side? Students, can you able to see? Okay. So now
Sir.
the R0, yeah, tell me. So now R0 is holding what? The starting address of the array. Now from that particular address, I have to retrieve the data, right? So I am initializing my counter, the size of the array to R1 register. So now you can see that the contents of the R1 is stored as 4. The size of the array. That's the number of elements which I am going to store there. So next, I am going to move the data which is stored in R0 to R2. So once this particular instruction is executed, what should be stored in R2? What value should be stored to R2? What value should be stored to R2? Once you have LDRH, R2, comma, contents of R0. What it is?
Addition R2
Yeah.
and R.
LDRH, I am telling. LDRH, what it will do? It will just load the data from the memory to the register. So what value it is going to move? The first number. What is the first number?
1122.
Yeah, 1122 has to move to which register now? R2.
2.
1122 has to move to R2. So now presently the value of R2 is 0. Once the execution of that particular instruction, the value of your R2 is 1122. Can you see this? The value of R2 at the register window. Can you able to see that one? In the register window, can you able to see 1122? Students, can you able to see that one? Now, I am going to subtract the counter. I am going to subtract the counter, which is R1. So when you subtract it, the counter of R1 will become 3. So once it is 3, I have to get the second number, right? I have to second the number. So presently the value of R0, which is pointing to the first location. So next I need to point to the second location. So now where the second element's memory address is starting, which address? Where the second element's memory address is starting, which address? Which address?
4 lakh 2.
Yeah, that is 2. Now I have to increment, but presently the address which is stored in R0 is 4 crore. So next it has to point to 4 lakh 2. So I have to increment that particular address by 2. So that is what add R0 comma R0 comma hash 2 is going to do. So once you execute that particular instruction, you can check in your R2. So R0 is now pointing to 4 followed by 602, that particular memory location. Okay. So it is 4 lakh 2 address memory location. It is going to be load. So now from that particular memory location, I have to retrieve the data. To retrieve the data from the memory location 4 lakh 2, what is the instruction? What is the instruction to retrieve the data from the memory location to the register? It is again load RH. So that I am going to retrieve the data into which register? R3 register. I am going to retrieve the data into the R3 register. So now you can see it here. R3 is holding what value now? R3 is holding what value now? Can you see it?
R0.
What R3 is holding? Can you able to see what the R3 is holding? Can you able to see the window or not? Register window.
3344.
Yeah, 3344, which is nothing but your second element, right? Which is nothing but your second element. So now those two elements has to be added. That is R2 and R3. And the final result, I'm going to store it in R2. So when you go for, any doubt?
No,
Any-
sir.
Okay. So in the next execution, it will add the contents of 1122 and 3344. The result what you are going to get, it is 4466. That will be stored in the register R2. So next, what operation? I have to decrement the counter. So decrement the counter, which is subs R1 comma R2 comma hash 1. So it will decrement the counter. So you check that CPSR register whether your 0 flag is 1 or not. So presently, what is your 0 flag? Your 0 flag is 0 only. So if it is 0, where the jump has to take place? Branch or not equal, because your 0 flag is not 1. So branch or not equal means it has to again repeat the process to up. Again, it has to go to the up and it has to start executing from there. Again, it has to add to point to the next instruction. Okay, so next again, it will check it out. This particular branch are not equal. Up it will go. It will add the contents. Now presently, the contents of R2 is 4 lakh 2, which I have retrieved the second data from the array. So next, once it execute, it will point to 4 lakh 4. Can you see that one? So now from that particular location, the data will be retrieved from 4 lakh 4. So again, it is going to retrieve. What is the data which is stored in 4 lakh 4? It is 4566. The data which is stored in the third array number. The third number which is been stored in that particular memory location is 4566. That will be loaded into R3. So next again, it is going to add with the result. The result what we are going to get is 89cc. So again, I am going to decrement the counter to 1. So it is not equal. Again, up it will come. So next again, it is going to fetch the array. So from the memory location pointing to 4 lakh 6. So next, it is going to retrieve the data from the 4 lakh 6 location, which is 1223. Next, it is going to add with R2. So R2 value previously it was there. The final result what you are going to get is 9BEF. Okay. So once the result you are going to get, that particular result you are going to be stored in the register R2. So next, once it is done, your R1 becomes 0. Now once the R1 becomes 0, so what should be your 0 flag here now? What will be 0 flag now? When the R1 becomes 0, when subtract is happening, your R1 becomes 0. Your 0 flag turns to 1 here. You can see it. Can you see that particular zero flag has become 1? Can you see it? Wherever zero flag has
Yes.
yeah, once the zero flag has become 1, this loop terminates. When the zero flag becomes 1, that is, once the value of contents of R1 becomes 0, your zero flag will be set, that will become 1. That particular loop terminates now. So now the control flow comes to your LDR. This particular part, LDR result I have to store, right? I have to store the result which have been obtained and which is stored in the register R2. The R2 is now holding the result. Now, once you are done, so now to which memory I have to load the result? I have to load the result in the address 4,100,000. Okay, this particular 4,100,000 memory, I have to store the result. So I am going to store that particular 4,100,000 into R0. So I am going to store the result. The result presently is holding in which register? R2 register. So that particular value I am going to move to R0. I am going to move to R0. So your R0 is holding the address where the result has to be stored. So what value I am going to move? I am going to move the 32-bit value of the result. So now, once it is done, halt. So whatever R0, whatever how the data will be stored now here, can you tell in your memory? So if I tell from this particular program, if I write it, so assume that my address will be starting from, so you're going to get 9BEF is the exam, is your result what you are going to get. So now can you tell what is the value which will be stored in 100 if the result is 9BEF? So whatever the result I have to store is how many bit of result? It is to be 32-bit result. According to the statement, it should be a 32-bit result what you have to give. So now, can you tell what you were in 4 lakh and 4,100,000, what is the data it will be stored? Can anyone tell the result? The result what you are getting is 9BEF. What will be stored in your 4,100,000? What it will be stored? Can anyone tell what it will be stored in 4,100,000? Can anyone tell? Which is the lower byte in 9BEF? Which is the lower byte?
EF, sir.
Yeah. So EF will be stored first. Next, in 101, what will be stored? In 101, what will be stored? The next byte is what?
9B.
9B. So next, 102. Any data is there? This one?
0,
What
0.
will be stored now? 00 will be stored. Again, it is 00. So this is the result what you have to see. Now you have to see in result in which address? 4 lakh address. You have to see the result in this particular address. Now, I have to take the memory window here once again. So I have to type the address. So 4 lakh 1 4 followed by 1 2 3 4 5 6. Okay. So anybody having any doubt whether the data specified is correct or not? 3 4 1 2 3 4. So this particular that I have to see. So now I have to execute this particular statement. Now where the result is pointing, it is pointing, it has loaded the address to which register now. The destination register, it has been loaded. Still it is not loaded. Okay. So when you press next, any doubt? Anybody having any doubt? Anybody having any doubt?
No, sir.
No. Okay. It will load the address of the result, which is 4,100,000 into R0. Here, you can see it here. And the next store instruction, what it will do? It will load the data from 4 lakh store the data which is stored in register R2 to the address specified by R0. So when you press next, it will be executed. So your 9BEF will be stored into the memory location addressed by R0. So if you go and see your 4000 address here, you can see what is the data which is there. Can you see that one now? Initially, what was there? Initially, it was 00 was there. Now, what is there in this particular address? 100, what is there? Can you see it? Can you able to see? Can you able to see what value is there in your 4 lakh 100 address EF? And your 4 lakh 1, it is 9B. And your 4 lakh 2, 00, 4 lakh
Yeah.
3, 00. Any doubt? Anybody having any doubt?
No, sir.
So this is how the program runs with respect to your fourth program. So anybody having any doubt? Anybody having any doubt? Anybody having any doubt?
No, sir.
Okay, if you don't have any doubt, it's well and good. So just go through the code once. So just the same code I'm going to paste for you in your group. Okay. So just go through the code once. So then you will understand everything. So once the class is over, so just what you do is over as the kill software. In the same fashion, you have to write the code. Okay. The same fashion you have to write the code. So once you have written the code, you just type it and execute it. So only from here you have to make use of the you have to make use of the kill software, because so your kill software will not work. Your browser based software will not work for the memory based operations. So whatever the operations I have shown, right, like altering the data in the memory, so that particular option is not there in your browser based. That is the limitations. Okay, so that's why we cannot make use of the browser based this one there. So if you have not having any doubt, so if you have any doubt, you just go through the program once. Now I will give 5 minutes for you. So if you find any difficulty there, or if any doubts you are going to have, you just ask there. So I will wait for 5 minutes. Okay. So just if you have any doubts, you can clarify it. So if anybody having any doubt, by the time I will post the program for you in your WhatsApp group only. So later, once I prepare the manual, I will share the manual along with that one. So just go through the code once, type it neatly. So if you have any doubt, you can ask. So if you have any doubt, so all of you following, right? Students, whether all of you are following,
Yes, sir.
only 5 or 6 are replying. What about the rest? Jayant, whether he is active? So now go through the code. So if you have any doubt, you can ask. Okay. So just take the code. So all of you got the code. I posted the code now. Okay. So just type it in the same fashion. So you will understand that one. So all of you understand the flow of the code, right? So all of you understood the flow of the code, I think. So if you have any doubt, you can ask. Anybody having any doubt? So have any doubt? So if you don't have any doubt, so we'll come again in tomorrow's class. So and we'll solve 2 more problems tomorrow. So anybody having any doubt, you just ask. Okay. So anybody having any doubt? So if you don't have any doubt, we'll just wind off the class now for now. Okay. Thank you.
Thank you, sir.
Okay.